Welcome to another installment of AP Computer Science. Ready to take notes? You better be, because today we're learning about inheritance. A key element of object-oriented programming is the ability to derive a new class from existing classes by adding new methods and redefining existing methods. The new class can inherit many of its attributes and behaviors from existing classes. The process of deriving a new class from an existing class is called inheritance. The more general class that forms the basis for inheritance is called the superclass. The more specialized class that inherits from a superclass is called a subclass or a derived class. In Java, all classes belong to one big hierarchy derived from the most basic class, called object. This class provides a few features common to all objects. More importantly, it makes sure that any object is an instance of the object class, which is useful for implementing structures that can deal with any type of object. If we start a class from scratch, the class automatically extends object, for example, is equivalent to. When a new class is derived from C creature, a class hierarchy is created, for example. This results in the hierarchy shown. The classes that lie closer to the top of the hierarchy are more general and abstract. The classes closer to the bottom are more specialized. Java allows for us to formally define an abstract class. In an abstract class, some or all methods are declared abstract and left without code. An abstract method only has a heading, a declaration that gives the method's name, return type, and arguments. An abstract method has no code. For example, all methods in the definition of C creature class are shown below are abstract. C creature tells us what methods a C creature must have, but not how they work. In an abstract class, some methods and constructors may be fully defined and have code supplied for them, while other methods are abstract. A class may be declared abstract for other reasons as well. For example, some of the instance variables in an abstract class may belong to other abstract classes. More specialized subclasses of an abstract class have more and more methods defined. Eventually, down the inheritance line, the code is supplied for all methods. A class where all the methods are fully defined is called a concrete class. A program can only create objects of concrete classes. An object is called an instance of its class. An abstract class cannot be instantiated. Different concrete classes in the same hierarchy may define the same method in different ways. For example, in addition to facilitating the reuse of code, inheritance provides a common base data type that lets us refer to objects as specific types through more generic types of references. In particular, we can mix objects of different subtypes in the same collection. For example, the data type of an instance of the fish class is a fish, but is also a kind of sea creature. Java provides the ability to refer to a specific type through more generic types of references. There may be situations that require a reference to an object using a more generic supertype rather than its most specific type. One situation when it is different subtypes of an object in the collection are mixed. For example, this is possible because both fish and mermaid are sea creatures. Note that fish and mermaid classes provide two different implementations of swim method. The correct method that belongs to the class of the actual object is located by Java Virtual Machine. That means that one method call can call different methods depending on the current reference of X. When a subclass redefines the implementation of the methods of its superclass, it is overriding the method. Note that for an overwritten methods in Java, the actual method to call is always determined at runtime. This is called dynamic binding or late binding. The principle that is the actual type of the object determines the method to be called is polymorphism, which is Greek for many shapes. The same computation works for objects in many forms and adapts itself to the nature of the objects. Overloading a method is often confused with overriding a method because the names are so similar. Overloading a method means to keep the name of the method but change its parameter list. In this case, a compiler can choose the method that is actually called because the signatures are different. The math class has many examples of overloaded methods. For example, math.max, AA, BB, math.max, int a, and BB are overloaded versions of the max method. The compiler determines which one to call depending on the type of arguments that are being passed in. In Lesson 14 about Boolean algebra, it was learned that Java has a class-like form called an interface that can be used to encapsulate only abstract methods and constants. An interface can be thought of as a blueprint or design specification. A class that uses this interface is a class that implements the interface. The interface is similar to an abstract class. It lists only a few methods, giving their names, return types, and arguments, but does not give any code. The difference is that an abstract class may have its constructors and some of the methods implemented, while an interface does not give any of its code for methods, leaving their implementations to the class that implements the interface. Interface and implements are Java reserved words. Here's an example of a simple Java interface. Any class that implements the comparable interface defines a compare_to instance method. Any object created from such a class includes the compare_to method. We say that the object implements an interface if it belongs to a class that implements the interface. For example, any object of type location implements the comparable interface. Note that this is not enough for the object to include the compare_to method. The class that it belongs to must say that it implements comparable. A class can implement any number of interfaces. In fact, a class can both extend another class and implement one or more interfaces, so we can have things like this. An interface is very much like an abstract class. It's like a class that can never be used for constructing objects, but it can be used for a basis for making subclasses. Even though you can't construct an object from an interface, you can declare a variable whose type is given by the interface. For example, if locatable is an interface defined as follows, then fish and mermaid are classes that implement locatable. You could say, a variable of type locatable can refer to any object of a class that implements locatable interface. A statement like Nemo.location above is legal because Nemo is type locatable and any locatable object has the location method. You're not likely to need to write your own interfaces until you get to the point of writing fairly complex programs. However, there are a few interfaces that are used in important ways in Java's standard packages. You'll learn about some of these standard interfaces in the next few lessons.